All right. Well, good afternoon or morning for some of you on the call today. Welcome to today's think tank session on exploring AI use cases to create value in intelligent buildings. I'm thrilled to have you all here for what promises to be an engaging and insightful discussion. Before we dive into our topic, I'd like to take a moment to let you all know that this will be an interactive session. We encourage everyone to participate, share their thoughts, and ask questions. We will be recording the session and the recording will be distributed to all those who registered for today. Now, I'd like to introduce Harry Pascarella from Harbor Research, who will be moderating today's session. Harry will kick things off with a presentation on our topic, and throughout the session, he'll open up the floor for discussion and questions. You're welcome to participate actively or remain as an observer. If you prefer, you can utilize the chat box, question box, and raise your hand if you'd like to join the discussion or ask a question. Thank you once again for joining us. And with that, Harry, I'll turn it over to you.
Thank you, Marta. I appreciate everybody's time. Looks like we got a great group of participants here today. So really appreciate everybody's participation and looking forward to a great discussion today. As Marta said, my name is Harry Pascarella, Vice President at Harbor Research. We've done a lot of work in collaboration with ASHB over the years, and excited to share some of that work and extend some of the thinking from some of that work here today. Quick overview of who we are. Harbor Research is a research and strategy consulting firm. We work with our clients to develop new growth strategies around emerging technologies. We've been doing this for quite a while, stumbled into this IoT and related technologies topic back in the early 2000s. Have a couple of pieces published in the Harvard Business Review on the topic of business models and strategies for what we like to call smart systems, which we think captures the true extent of the scope of technologies that are impacting various vertical segments today, and have had a significant focus on buildings of all shapes and sizes, and companies serving those buildings of all shapes and sizes over that time period. We are consistently engaged with ASHB on various sorts of research activities. You'll see a QR code in the bottom right corner. If you're interested in learning more, feel free to take a spin, look at that QR code, or reach out to Marta or myself for more information on those activities. All right, as for today, we will have a quick introduction to the topic of AI. I'm sure everybody's heard about it. I'm sure everybody's almost tired of hearing about AI at this point, but we'll hopefully try and make this conversation much more directed at the buildings environment and try and learn together a bit about where things are at today, where they might be heading, and how companies might be able to best position themselves in the market to support intelligent buildings applications of AI. We'll look at this overview of AI use cases in intelligent buildings, look through kind of a framework of how we think about various applications specifically related to intelligent buildings, as well as some examples of what's going on in the marketplace today. We will hear from a company that is currently supporting customers with AI-enabled solutions, and we'll try and have a good 20 minutes or so for an open discussion, if not longer than that, where we can answer questions, we can talk through particular topics of interest, and hopefully give everybody some knowledge and some understanding of the space and where it might be heading. Okay, with that, I will dive in. So quick introduction to AI. While AI has increased significantly in hype and popularity over the past couple of years, mostly around the consumer side of things with the invention and coming to market of ChatGPT, AI has been coming for a while. In the second half of the 20th century, it really started with things like cybernetics, reasoning and classification, and maybe more general data analytics. was what we call the first evolution of AI, where you start to take data, computerize that data, and be able to analyze it in a way that you get understanding and outcomes from that data. The second evolution was in the late 20th century into the 2010s, where really we started seeing a lot more business intelligence. So as computers began to proliferate, as more data was collected on business activities, this idea of business intelligence grew in importance, and many solutions were brought to market to support businesses trying to understand more about what they were doing internally, how they could better support their operations, and how they could better support customers and drive value for customers. During this time as well, additional research and development of artificial intelligence capabilities and modeling schemas came into play, convolutional and recurrent neural networks, and that built upon the more traditional regression and classification types of artificial intelligence that have existed for a while. And finally, over the past decade or so, we've gotten much further into things like deep reinforcement learning and now generative AI and transformers, which further help drive value from artificial intelligence technologies by modeling thousands, millions, even billions of different types of data points and variables to help understand and apply analytics in a way that creates new value for the users of those systems and more broadly the businesses that employ them. So we are in this kind of third evolution of AI as we've described, and of course with each of these evolutions there was significant amount of hype, and then it took a while for different companies to figure out how to apply these technologies to support their businesses and their customers. This breaks it down a little bit further into the different types. It's sometimes helpful to think about it from these different types and how these different kind of methods or approaches to AI technologies really driving AI combine and to drive out solutions. And so we've seen a lot occur from a development standpoint around generative AI and large language models, and all of that has happened, like I said, in the past couple of years. That space continues to get innovated within, and not only are we hearing about large language models, we're hearing about small language models that are really meant to drive very application-specific outcomes and values for the companies that choose to use them. But at the same time, though, it's important to note that not all AI is generative AI. There's many different values and applications and use cases for AI that have nothing to do with chatbots or answering questions or generating images or things like that. And even some of the most basic forms of AI, like classification, regression, and some of the more advanced, like convolutional neural networks and recurrent neural networks, can really support some of the intelligent buildings applications that we'll talk about today. The space is characterized by many overlapping terms and technologies. It's honestly quite difficult to try and differentiate between all of these things, and I'm sure for anybody who's tried to work their way through the various entanglement of terms and technologies, that it can be quite confusing. So we've tried to differentiate a little bit between some of the major terms. Data science we see as the overarching term, the ability to collect and analyze data in a way that can help in a range of certain tasks. This can be anything from simply organizing data sets so that they can be searched through and looked at on maybe the more simple end of the spectrum, to these very in-depth and highly dimensioned artificial intelligence, deep learning, machine learning technologies. Data analytics is somewhat broader. It includes and overlaps significantly with artificial intelligence, but there's ways to perform data analytics, of course, without having to actually employ AI techniques. So, I'm sure everybody's familiar with, doing regression analyses. You can do these kinds of analyses on data without anything to do with automating those analyses or predicting outcomes based on those analyses. And all of that is more kind of static data analytics. And whether that's descriptive analytics or diagnostic analytics, you can use data in many ways to understand and drive this value. But what artificial intelligence does is not only conduct those kinds of data analytics, but then drive an outcome based on those analytics, whether that be, as I said before, to predict where the next data point might fall, and make decisions based on that, or alert somebody based on that. And so that kind of artificial intelligence brings in a lot more automation and predictive capabilities to what might be going on with a system or with a data set. Machine learning we typically refer to as applied AI. So it's basically training models and machines to learn from data points and improve that learning over time. And it doesn't really need to be explicitly programmed to do this, but instead it finds ways to synthesize, analyze that data, and offer insights that actually improve over time. So a lot of different technologies and terminologies here. Sometimes helpful to break it down a bit and also understand that at the end of the day, much of what's talked about from an artificial intelligence standpoint could be in many different of these boxes or a single one of these boxes. And it may not be immediately clear to folks who may be looking from the outside in what that artificial intelligence really is. So with that kind of baseline, we can start to think about what all of this means for intelligent buildings. Start with a general set of trends and forces. A lot is occurring in the marketplace. Of course, we just talked through a couple of the technology trends, but in intelligent buildings specifically, of course, with all of the sensors and systems that are producing data now, there's a lot more feedstock to data analytics and artificial intelligence solutions in the form of various types of data points and data streams that can inform higher value analytics for customers and inform outcomes based on those analytics. A lot of that data today is unstructured, there's even applications for machine learning to help structure and organize that data, as I was saying previously. But combine different data types and data streams to develop a more complete picture of an environment and again analyze that data more effectively. At the same time, there's a significant amount of low code, no code solutions that are making it possible for non-data scientists to perform data science activities and tasks within their businesses and really just drive the value out of it in that way as well, and also build specific applications to take data and analyze it in certain ways. So all of that is setting the stage for more broad use of these kinds of technologies moving forward. Customers, of course, are dealing with a reduction of overall workforce or increasing lack of expertise related to their building systems, as well as related to these new technologies as they come to market. Customers are looking for improved expertise that relates to, or improved experiences that relates to these systems, and they're particularly on property management side of things, these companies are looking to improve the experience of their tenants and customers alike. On the supply side, there's there's been significant investment in artificial intelligence solutions, both in the form of investing in and working with and partnering with innovative suppliers in the marketplace, as well as developing some of these solutions internally. A lot of businesses have a lot of data and just don't know what to do with it. And so the more that these solutions come into play and become more mainstream, businesses are finding that they can unlock more of this value from their data and their customers' data, and are using that to develop new solutions and services for their customers. Not to mention incorporating into back-end systems to improve and make more efficient their operations. And all of this is occurring in the context of greater scrutiny, greater understanding of AI and the problems it might cause. Data privacy and data ownership concerns are the highest they've ever been, and will continue to increase in importance moving forward. And everybody's looking for solutions, whether it be for sustainability or other sorts of outcomes that can help better drive ROI for their systems. So when we look at how AI can be applied specifically in intelligent buildings, we look at this maybe a little bit different than if I were looking at a particular business's context, or applying artificial intelligence to improve a specific business's or supplier's operations. So of course you can apply AI in everything from human resources applications and other things like sales and marketing. We're talking much more about we have all of these intelligent building systems, these smart and connected devices and systems within buildings, all these sensors that are now communicating data about what's going on within that building. How do we take that data and do something with it? So we look at 4 different categories of applications. Those associated with the assets and operations. So, asset management, reliability, uptime of certain systems, as well as just overall operations visibility and the optimization of those operations. We look at how these solutions might impact employees and tenants or occupants. So, things like space management and how occupants, are actually conducting the work that they're doing within a building, how these solutions can impact that, as well as things like safety and security. A big category is environment and resources. Of course, on one hand, related to things like sustainability, but also in many cases related to reducing costs or making resource usage more efficient. So, of course, resource utilization management is a big one in the form of energy management. Environmental condition management is particularly important in many building types, as well as just overall safety and compliance as relates to the use of certain systems and products within these environments. And then there's a whole host of data services that can be informed by artificial intelligence, which are enabled really through the collection, organization, and management of data from OT and IT systems. And so when we look at these different types of applications, AI can have an impact across every single one of them. But the big question is, where and how will it be adopted in the near term, and what should suppliers be focusing on to bring solutions to market to better support customers? So we'll look at a few areas here today. To think about AI within the context of these buildings, when we say artificial intelligence in general, it's all about collecting data, putting that data into models that have been trained based on existing data or synthetic data, even sometimes over time, to predict certain outcomes and then inform decision and actions. We have here based on, say, a control system, BAS or BMS actions, but this could also be just how certain companies or stakeholders within a company interact around certain data systems once outcomes have been predicted based on that data. This ends up being a loop, and the beauty of artificial intelligence is that it improves over time with use, and so the value that you start out with may just increase and compound over time as these systems are used and developed around specific applications. It's important to note that these AI technologies themselves evolve from more basic to more advanced over time. So, I know we talked previously about the evolution of AI, but a lot of these models, a lot of these solutions started as basic and supervised ML and rule-based algorithms with predefined settings. So people are more involved in the actual training of models based on the outcomes that they want to develop and predict over time. And there's still very important values that could come out of these, but over time, as different AI solutions improve, as the technologies and approaches to AI become more complex, you're able to start to generate more value, more compound and complex values coming from these solutions. And so a lot of this is based on the combination of different AI technologies to support a particular outcome or use case, or the improvement of an AI model and the outcomes it's achieving over time. So before we get into some specific examples of use cases, we'd like to do a quick poll of the group here to understand where folks believe that out of the list here that AI would be adopted the quickest. We've done some work in this over the past year or so, and are interested to see where the folks on this call believe that solutions will be applied soon. So we'll give folks a little bit to respond to this, and then we'll take a look at the results together. All right, awesome. So looks like a great set of responses. Predictive maintenance, HVAC optimization seem to be the top, with energy being number 3. I think that's pretty in line with what we're seeing in the marketplace, honestly. Predictive maintenance is probably a pretty broad use case. It can be applied to many different systems in these environments, and would seem to be one of the areas that has gotten a lot of attention even before the recent hype around artificial intelligence solutions, because based on a set of data analytics that has been available for a while, but is now being improved by artificial intelligence. So it's very interesting to see that. It likely overlaps some with things like HVAC optimization, where you are optimizing the functioning of all of these different systems and devices that make up an HVAC system to better perform those activities and do so in a way that reduces things like energy cost over time, as well as improves the comfort and the environmental conditions within a building. Then the energy management one always comes up as a key area, because of it can be a great opportunity for cost savings for customers, and as well as supporting their sustainability goals. So very interesting to see all of that, and I think ultimately trying to understand how these things, where might the focus for customers be, will be an interesting thing to be thinking about as we move forward. Ken, any comments on this? Does this all make sense so far?
Where does fault detection fit in all of these, or access kind of?
Yeah, no, I think fault detection in many places, or can fit in many places. You could probably develop a list of 30, 40 different applications. It's sometimes difficult to even understand exactly the different constituent pieces of these things. Of course, I think it comes in from an HVAC optimization standpoint, of course, from a predictive maintenance standpoint. but likely is across a number of these systems and potential opportunities here. Great. So as we think about various use cases, again, there's so many different ways that artificial intelligence can be applied. And so we're never trying to necessarily select or acknowledge absolutely everything. But wanted to offer some examples and how some of those examples might fit across some of those key application and use case categories that we were looking at previously to inform particular outcomes for customers. More in maybe the basic and more simple categories, the bottom left of this chart, you have things like HVAC optimization, you have energy monitoring and savings recommendations, and water leak detection. These are all relatively basic applications of AI, as you are typically, either focused on a single system or a few systems, and very specific data points within those systems. And so as we go from the bottom left here to as we move to the top right, you start to see the combination of a lot of these different applications to do things like preference-based environmental control and HVAC optimization. So, whether it's different office suites within an office building, and these folks want to be able to control or have certain, environmental conditions based on their preferences, being able to optimize the solution to support that, or the system to support that, is an interesting opportunity, but also in the sense of where you have multi-use buildings where the environmental conditions are critical to the operations within those buildings. You can have some very specific control and automation based on all of that. Eventually, and as a lot of these systems and data values get combined and start to inform each other, more automated and integrated building system digital twins and the related optimization of those systems can be informed by all of these different data types. And so while there are some solutions out there today that are approaching this kind of state, I think we're still relatively early on in the ability to collect all the data that's required to support some of these applications, as well as feed it through the right processes and have the right sophistication on the customer side to be able to properly use all of this. And so many different capabilities are out there today, some very focused, some very, simple in trying to, get at what, a very particular value or focused set of values for customers, while others are trying to be more broad and focus on more complete building control, automation, and optimization based on data coming from these systems. There are many, many, many solutions, and we've covered quite a bit in our research. We've highlighted a couple of here, more so just as examples than anything else. There's some examples of case studies on this page. There's some examples of companies on this page. By no means are we saying these are the only solutions out there, but tried to organize some in some of these particular areas of interest and hotspots that we've seen pop up in predictive maintenance, as we had seen earlier with the poll, and energy management, as we had seen earlier with the poll, as well as then occupancy related items and safety and security. And so again, every single company that supplies solutions to buildings environment can experiment with AI to better support the outcomes that they're trying to achieve with their customers. But it's really trying to identify what values you're trying to create with customers. And that can be an extension of the value that you already provide today, or that could be a whole new set of values that can be enabled by software and artificial intelligence that customers are looking for. And so, one of the things that we try to do is we look across what's being provided today, but ultimately you really have to understand what that customer perspective is. What are they looking for? What are their key pain points? How do they think about their operations? And then how do we apply solutions, whether they are AI enabled or not, to better achieve those outcomes and goals for customers? So there's a few examples here, and I think we will plan to hear from a company that's trying to do some of this here shortly as well, really just as an example about what can be done, and hopefully give folks some ideas about how to think about this and talk about this moving forward. Whoops. Here we go. So the last thing I want to talk about before we have another poll and open up the discussion a bit is just thinking about AI solution positioning, value creation, and value capture. We go through this a lot with our clients, understanding on the top level of this chart, what are the values being created? So what is the ideal customer experience? What do they need? What are the outcomes that they're trying to drive? And how do they get value from particular solutions or offerings? And so defining that, we think, is first and foremost the approach to defining where and how AI can be used. And then secondly, then coming back and saying, well, how do we as a company actually capture that value? And make sure we establish ourselves in the marketplace so that our lunch doesn't get eaten by others, other disruptors or other more technology advanced players or whatever that might be. And so looking at those value capture models, those control points are ultimately interesting as well. And these can all be defined very differently. These, the words on the page are really just examples, but hopefully this provides a decent framework for folks as they think about where AI might add value the most for customers. All right, we will do another 2 quick polls, and then I will hand it over to hear from a company that's doing this right now. So, oh, great, Mario, it looks like both are in the same poll. So there's 2 questions here. I'm interested in where folks on this call who are developing AI solutions or are thinking about developing AI solutions, where are you at today in your development? And then secondly, what are some of the biggest challenges that you might face? So if we can take maybe 30 seconds or so to respond to these polls, we can have some topic areas as we go into the open discussion portion of the presentation. Great. So we can leave that poll open, Marta, until we've gotten a good amount of responses. But in the meantime, I can hand it over to Ryan Brown from IntelliGlass to take us through what their solution looks like as an example of how AI can enable greater values for customers. And hopefully, again, it will spark some thinking and we can drive some discussion around this moving forward. Ryan, you want to take the screen from me?
Well, I will. First of all, Harry, great job. Thank you so much. All right, let me take you around this dashboard. IntelliGlass was established in 2019 in Pasadena, California. What we have been working on since that time is that we brought initially 2 groups of people together to specifically focus in on how to apply AI to the operation, principally of office and medical office buildings. So we have a particular target in our business model. So what we have done here is we're really trying to service the need of building engineers at the bottom of the food chain to see and within 3 clicks to get to anything which is in fact not operating within appropriate norms. So in addition to what you're going to see that we do in the building, we're recording 24-hour-a-day weather that's scrolling across the top. And we are also counting the number of people, and we know about how they are distributed within the building. So those 2 factors, along with all of the information that I'm going to show you, will sort of give you the database that our AI program is in fact developing. So over here, we have a dashboard up in the left-hand corner. Why? Because if we have a client that has 15 buildings, you can log on to any of the buildings and scroll immediately from one to one. So there's a sense of quickness, of ability to get from problem to a solution or starting to find an answer to a solution for any anomaly that's being operated. This building, again, is 114,000 square feet, and it was built in 2008. And to tell you the truth, it had nothing in the entire building was in any way sensorized. So instead of reading out a comprehensive HVAC system, we're comprehensively reading out the performance standards, performance of items that are sensorized using equipment that we've installed. So the boiler over here, domestic hot water, supply side, return side temperature. We know those anomalies, and as I go through this, if anything is an anomaly, it alerts immediately down here in this particular area where it says alarms. Cooling towers, we have 2. So each one of these pieces of equipment is individually described graphically so that you can see where and what might be alerting. We have air handling units. We have 3. They're contained on the floor in each of the 3 principal floors. And then finally, we have relief fans that operate in conjunction with the air handling units when it's necessary to pump out more air to achieve the stated goals with regard to temperature in the building. So all of those data points are woven together so that in one click you can see basically the entire system. So if there's an HVAC system in there, it's integrated into this kind of demonstration with regard to what we can observe immediately if I'm a building engineer or anybody up the food chain of the business. We've learned also a few interesting things. We count the number of people that go in and out of restrooms. Why? Because this landlord wanted to know that. If it exceeds 30 people on the use, the day porter gets a notice on their device to correct the problem and clean that particular restroom quickly. We're doing the indoor air quality. We're recording that, and each time these numbers move, what you're actually seeing is a transfer of data between the artificial intelligence and the building, back and forth in real time. We're also tracking in real time energy consumption within the building, the kW H use and the actual dollar amount. And then we have a set of charts over here that drill into the energy which is saved. So because this building basically didn't have very much to sensorize, and we've done pretty much all of it, I want you to understand the density with which we install specialized sensors within the building. averages out on a building like this about one sensor for every 700 square feet. And each one of these sensors, if in fact it's not operating properly, and this is the ASHB standards here for temperature, above 79, below 67, it would alert by changing colors. So then if I go to the sensor that would alert, what I can do at that moment is then click on that sensor, and I can see the airflow, the cooling set point, damper positions, heating set point, and I can see the actual, say, temperature. So it's within the appropriate tolerances, and it means, well, this one's operating appropriately. So if it's not, what you have the capability to do is to immediately from this website project on to an outside vendor or anyone else that needs to know what's not working appropriately with that particular at that particular area within the building. We have inventory management. We have in this building installed, I think, about 290 of these devices. And one of the things that we have done, because we've learned this based upon our own experience, is that we not only are looking at the building, but we are looking at the tenant space. So each tenant, if I'm the landlord, you know what I want? I want happy tenants. I want people who feel involved in the building. This is Suite 100 on the lower level. And we have the indoor air quality, temperature, humidity, CO2, PM 2.5 VOCs in that space. So again, what we're attempting to do is to demonstrate to people who are actually paying the rent in the building that their building tenant space, that their tenant space is in fact being appropriately operated. These kinds of, this page is actually customized for each particular building that we do it, based upon a discussion that we would have with the landlord as to what kind of things he would like to see being used, what kind of data that they may want to use. So we've got the dashboard back here. I have got
Ryan, what I was thinking is just because of time here, and I want to leave a couple minutes for questions. When we with all of this data, what kind of solutions does AI help augment for taking this data beyond just the visualization and even maybe more simple alerts and alarms to actually impacting outcomes in these environments? What could AI do based on all of this that you guys have been working with?
First, it gets smarter and smarter as time goes on. So the program itself, excuse me, now exceeds 90 million lines of code. We've been continuously evolving and developing the AI program. From the time we switch it on, typically it takes the AI about 18 months, not to get to complete learning, but as the additional data grows on a daily basis, the AI begins to make more and more accurate predictions. For example, the sun comes up, there's a heavy solar load on the eastern side of the building. We know the temperature, we know the thermal impact of that, and she becomes probably capable of changing things to as much as half a degree to pre-cool that or to accelerate cooling because of that particular impact in the from a heavy solar load on that side of the building. So she's really doing that through an entire range of issues. Population within the building, it's amazing. We can see, we know the number of people that come in. We know when they come in. The AI will in fact detect that there's on Tuesday morning in this particular conference room, there's 40 people crammed in. She will see that pattern. And then she begins to become predictive. And when we install this system, what we're really doing for the first probably 3 months is we're running in parallel with the HVAC system or any system which is in the building, so that the building engineer gets to understand and grows in confidence that, yes, the AI is making some very good decisions that I would normally not be able to make because of the detail with which we can now project when things should be changed, altered, or turned on, turned off.
Yeah, that's great, and I really appreciate Ryan the overview and the inputs here. I think it's very interesting to see an example of how these different data points can be combined and support some outcomes. And I know, like you said, it does take a while for an AI to really comprehend and understand everything that's going on. The more data you have, the faster that all goes. So if you're building that data from scratch, of course, it might take a while, but I would hope and think that many companies have a significant amount of data, and that kind of stuff can be helpful over time. But
Harry,
yeah, no,
we're
this is
collecting
great.
over 1 million data points a day in a 100,000 square foot building. So the
Yeah,
depth and breadth of the data available to the AI program is extremely substantial, and that's one of the reasons I think we can come to these kinds of small but coordinated shifts in the operation and of the systems that are in the build.
Yeah, no, that's great. Well, like I said, appreciate it, Ryan. I do want to leave the last couple minutes here for questions and a brief discussion if there are some. I'm going to just take the screen back from you and share my screen, and then I can highlight any other questions that folks have. Marta, I don't know if you want to quickly post up the poll responses. Okay, and looks like on the front end, there's a lot of yeses at various phases. That's great to see. We would assume that there would be, and then a few no's, but interesting to see that folks are planning on it, looking at this stuff, and then looks like a whole host of various challenges and pain points here, especially maybe chief of which is unclear ROI. So I do see a few questions in the chat. I lost the Q&A window, so I might be missing some things. But it looks like there was a question. Let's see. Specifically, Ryan, directed at you about have you set it up for demand response and integration with utility projections, or is this mostly focused on the building tenants at this point?
We are using this from the viewpoint of an owner of the building wanting to satisfy their tenants. So we do not alter anything with regard to utilities coming into the building. But once it's in the building, then we're basically arriving by all the steps that we go through. The average reduction in total energy consumption is 30%. We get to that point almost every building. So that's the primary economic benefit, but it's based upon better control of energy in the building and all the HVAC, lighting, all the systems that we sensorize.
Right, and I think as we've spoken about before, one of there was another question here about are the AI's automated changes limited to space temperature and set points and so on? It can also be related to variable rates as well, right? The kind of external data feeds that might come in around the cost of that energy usage.
Yes,
is that right?
Yeah, I'm sorry. Yeah, the AI knows that here in Southern California, I have 4 different daily rates. And yes, the AI will understand that, and she will cool down particular areas within the building prior to the rate change going up. So yes, she tracks the cost of electricity and can make projections as to how much we should cool down the eastern side of the building before 2 p.m. when the rates go up. So that we absolutely do that.
Yeah, that's great. Well, I know this is a massive topic. I know we're at the top of the hour here, and I do appreciate everybody for joining. Ryan, maybe if you want to post your email in the chat box, and if you look at the chat box, you can see a few of those questions that are open and hanging from folks that were kind enough to ask. And then, if folks would like to follow up with myself or Marta or Ryan on any of these topics, really what we wanted to do again was just kind of maybe open the can of worms, if you will, and demonstrate and show kind of how these different AI solutions might be able to be applied in buildings and give folks some things to think about as they proceed down their development roadmap here. So we could spend ages, I'm sure, talking about very singular use cases or all of them above, but hopefully this was just helpful in maybe expanding how people think about artificial intelligence as it relates to their businesses and the solutions that they provide to customers. Thank you, Brian.
Thank you.
Yeah, go ahead, please.
There are some challenges as it relates to the legality if something goes wrong. I mean, yesterday on Monday Live, somebody said that, the fear is who do I sue if things go wrong and the building isn't cooled or the cooling tower doesn't work? So I think we have to look at the positives, but we also have to look at the regulatory opportunities as well, and legal.
Oh yeah, for sure. And we actually are working with some companies too who are developing warranties and insured guarantees for certain outcomes and things like that, so that you can, as a company supplying an AI solution, have a monetary backed guarantee and warranty that solution will achieve outcomes or achieve the outcomes that you say it will, as a hedge against some of that stuff. But there's so many different layers to this, and like you said, so many challenges that need to be solved as you head forward, and a lot of those need to be addressed on a case-by-case basis. So I appreciate that input for sure. Thank you. So thank you, Ryan. Marta, I don't know if you have any closing words here, and otherwise I appreciate everybody's attendance and participation today. And as always, please feel free to send me an email or connect with Marta, myself, or Ryan on LinkedIn, and we'd be happy to follow up separately.